Hey everyone, welcome to this episode of KuTube. Today's lesson is really going to be focusing on solving multi-step equations. Before we begin, make sure you have some of the following materials out. You should have a piece of scrap paper with today's date and the lesson title on top. You should have a pencil out and make sure you have a pen out for some corrections. Once you're ready, let's get started. Alright, so before we begin today's lesson, we really want to focus on the difference between expressions versus equations. We've done a lot of work with expressions, so let's kind of zoom in on this part of our flowchart first. Remember, when we're dealing with expressions, there's nothing to solve. You're always going to be simplifying. So whenever you're dealing with expressions, you're typically going to see the directions say to simplify. There are two major types of expressions. We have numerical expressions, which are any expressions that contain numbers and operation symbols. And we have algebraic expressions, all right, which contains numbers, operation symbols, and variables. Remember that when we're dealing with numerical expressions, we use our good old-fashioned order of operations. However, when we're dealing with algebraic expressions, we've got a few steps. Anytime we're dealing with an algebraic expression and we're asked to simplify, we need to first get rid of any parentheses by distributing or multiplying. Ooh, that says multiple. It should say multiply. I apologize. Let me fix that really quick. All right. The second thing that we should be doing is combining like terms. And finally, making sure to write your answer in proper form. Today, we're really going to be focusing on equations, all right? As we continue through this unit, we're going to take what we know about algebraic expressions and now apply it to solve algebraic equations. Whenever you're dealing with equations, you're going to be asked to solve. And the major way you know the difference in an expression versus an equation is that an equation contains an equal sign. In order to solve an equation, we simply must first and foremost simplify each side of the equation. Then we're going to use our inverse operations in order to isolate our variable. So let's take a look at how we can kind of apply this. Before we do, I would highly suggest pausing the video for a moment and kind of writing out this flowchart at the top of your notes. This is really going to give you a good idea as to what part of our unit we are, and it's going to give you some good helpful steps as we do some examples. So once you're ready, unpause the video and then we can continue. All right, so before we begin, let's kind of review. Our first problem here, I would like for you guys to copy this down in your notes. We have 5 minus 3 times the difference of x and 10 minus 2 times 3x. Remember in class we talk a lot about the importance of reading the problem so we know the operations. Before we begin simplifying, I want to simply ask you guys, is this an expression or an equation? Good, this is an expression. We know this is an expression because it doesn't contain an equal sign. So we're dealing with an algebraic expression and all we can do here is simplify. So let's kind of go through this process. I'm going to take a look at my steps here and I'm going to ask, can I get rid of any parentheses? Yes, right? So the first thing I'm going to do is I'm going to bring down this first 5 and then I'm going to ask myself, what number am I distributing? Good, I'm distributing that negative 3. So I'm going to take this negative 3 and I'm going to distribute it to each term inside the parentheses. What's negative 3 times x? Good, negative 3x. What's negative 3 times negative 10? Excellent, positive 30. Then I stop distributing because my parentheses have ended. Now, the last term of our problem, are we distributing or just multiplying? Good, we're just multiplying, right? And this last kind of expression here, we're just doing negative 2 times 3x. I'm not going to bring down that minus sign because I'm going to simply look at this and say, what's negative 2 times 3x? And that gives me negative 6. So I'm going to bring down my minus 6. Awesome, so we finally have gotten rid of all of our parentheses by distributing and multiplying. My next step is to combine my like terms. Can you identify my like terms in this expression? Good. We've got negative 3x and negative 6x. Can you identify the other set of like terms? Excellent. Positive 5 and positive 30. Now, since I know my answer must be in proper form, remember in class we talked about how variables always come first and constants come last. So what should we combine first? Our variables or our constants? Good. Let's save a step and let's combine our variables first. What's negative 3x minus 6x? Good, negative 9x. What's positive 5 plus 30? Excellent, positive 35. So my final expression in simplest form is negative 9x plus 35. Awesome. Now that we know how to simplify expressions, let's talk about how will we solve multi-step equations. So today's lesson is really going to be taking what you know about simplifying and taking what you know about inverse operations in order to solve multi-step equations. Now, when we first started talking about equations, a lot of you guys might have said, well, I can do this mentally, right? If I give you some easy equations like this, most likely you can figure out the value of x that will make this equation true just by using guess and check. However, as you noticed on this page, some equations become more and more complex, and it becomes really hard in these scenarios, especially the ones highlighted in orange, to guess and check. So as equations get more complex, we're going to need to use algebra to help us find the solution. So as we go through some of the problems today in today's lesson, please make sure you pay attention to some of the algebraic steps that I'm showing and modeling. Let's start off with our first example. In example 1, we have 4 times the difference of 2x minus 5 is equal to negative 4. Is this an expression or an equation? Good, this is an equation, and we know it's an equation because it contains an equal sign. So the first thing I'm going to do is what we always do. I'm going to put a dotted line down the center of the equation to separate this from the left side and the right side. When we put a dotted line, we're simply saying that there's an expression on the left and there's an expression on the right. So my first step to solve any multi-step equation is to first see if I can simplify either of these expressions. Can I simplify my left expression? Yes, I can. All right, so let's go ahead and do that. So the first thing I'm going to do is I'm going to simplify this by distributing. We're going to take that 4 and we're going to multiply it to 2x, which gives me 8x. I'm going to take that 4 and multiply it to the negative 5, which gives me negative 20. I'm going to bring down my equal sign, and I'm going to bring down my negative 4. Once again, I'm going to ask myself, okay, we've reset our equation. We have an expression on the left side, and we have an expression on the right side. Can I simplify the expression on the left side? No, I can't distribute, I can't combine like terms. Can I simplify the expression on the right side? No, it's just a negative 4. I can't do anything with that, right? Okay, so now finally we can use some inverse operations. We're going to go through all of those same steps that we're used to. What variable am I solving for? Good, x. What two annoying numbers are standing in the way for me getting x by itself? Good, negative 20 and positive 8. Which one should I get rid of first? Excellent, the negative 20. So I'm going to add 20 on both sides. What I do to one side, I do to the other. Draw a giant equal sign. I'm going to switch back to dark blue to show that's my new step, my new equation. I'm going to start from the left and bring down my 8x. Negative 20 plus 20 does cancel out. Is going to be equal to, what's negative 4 plus 20? Excellent, positive 16. All right. Now I've reset my equation, but now I have to isolate my variable x. And the way I'm going to do that is by using inverse operations. So I'm going to switch to orange, and now we're going to show how we're going to use inverse operations to isolate x. So what annoying number is standing in the way for me getting x by itself? Good, 8. To get rid of the 8, my coefficient 8, I'm going to divide both sides by 8. Finally, 8 divided by 8 gives me 1. I just write it as x. X is equal to, what's 16 divided by 8? Good, positive 2, and I circle my final answer. All right, that was a lot at once. All right, so we're taking a look at how we're using what we know about simplifying to solve these multi-step equations. Let's move on to example 2. Take a moment, if you need to, pause the video and write down example 2 in your notes. All right, if we take a look at example 2, we have negative 6 times the quantity x minus 2 minus 5 equals negative 11. Is this an expression or an equation? Good. This is an equation because it contains an equal sign. So my first step is going to be put a dotted line down the center of the equation to separate my expression on the left and my expression on the right side of the equation. I'm going to once again ask myself, I'm going to take a look here. You don't have to highlight it. What I'm highlighting is kind of like what I'm looking at. On the left side of my equation, can I simplify that expression? Yes, good. So what can I do first to simplify this expression? Excellent, I should distribute the negative 6. What's negative 6 times x? Negative 6x, excellent. What's negative 6 times negative 2? Good, positive 12. And then I'm going to bring everything else down. The minus 5 is equal to negative 11. From here, once again, I'm going to look at this as the left side expression and the right side expression. Can I simplify either side of the equation? Yes, I can simplify that left side, and I'm going to do that by combining my like terms. What are my like terms on the left side of my expression? Good, positive 12 and negative 5. So I'm going to bring down my negative 6x, always variables first, and then I'm going to ask myself, what's positive 12 minus 5? Good, positive 7 is equal to negative 11. Now once again, I'm going to go back and reset. Is my left side, can I simplify my left side? Can I simplify my right side? Can I distribute? Can I combine like terms? No. So finally, we can now use inverse operations. So I'm going to change this to light green. I'm going to show all my inverse steps in light green. We're going to go through that whole process. So answer with me out loud if you're at home. What variable am I solving for? Good, x. What two annoying numbers are standing in the way for me getting x by itself? Good, negative 6 and positive 7. Which number should I get rid of first? Good, the positive 7. How do I get rid of the positive 7? Nice, I'm going to subtract 7. What I do to one side, I do to the other. Giant equal sign, start from the left, go to the right. What should I bring down? Good, the negative 6x. What's positive 7 minus 7? That's right, those cancel out to 0. Equals, what's negative 11 minus 7? Good, negative 18. Am I done? No way, right? All right, let's keep going. What variable am I solving for? X, good. What annoying number standing in the way? Negative 6. To get rid of that negative 6, I'm going to divide both sides by negative 6. And now I'm going to simplify that. Negative 6 divided by negative 6, dividing those coefficients by itself, that's going to be positive 1. So I just left with x is equal to, what's negative 18 divided by negative 6? Good, positive 3. Really paying attention to those signs. Hopefully you're following along by participating out loud. If you feel like you are kind of struggling with that, making sure you're really taking the time to pause and rewind the video to re-look at how I was solving that. All right, we're going to skip example 3, and I actually want to give you an opportunity to try some examples out by yourself. So based on those first two problems that I modeled, you should choose a leveled problem. What I'm highlighting in yellow, these I would say are more like level 1 examples. Remember, draw that line down the middle, simplify both sides of the equation. If you feel like, all right, those two problems are pretty easy, you might want to try these starred problems. All right? So on your scrap paper, I'm going to recommend that you pause the video and you're going to choose two problems based on your level of understanding. Either choose the two yellows or choose the two orange. When you're ready, unpause the video and we're going to go over the solutions. All right, so hopefully you've tried the two problems of your choice. If you chose the two yellow examples, let's go over those first. At this point, I would recommend that you take out a colored pen and let's go through each of these responses. As you're looking at my answer, I know it's really simple just to look at my solution, but instead we really should be paying attention and checking our algebraic work. In this first part, you're going to notice I distributed the negative 6. Check to see if you've added 30 on both sides. Check to see if you divided both sides by your coefficient of negative 12. And finally, did you circle your answer in proper form? X is equal to the number 3. Do the same thing for the second example by pausing the video, taking your pen out, and checking your steps against my steps here. Awesome. All right. If you didn't do the yellow and you did the orange, these are the two orange examples. All right. So once again, you're going to take a colored pen and you're going to cross-check each of your steps against each of mine. Did you distribute the negative 5 correctly? Did you combine like terms? Did you use inverse operations to isolate your variable x? And finally, did you get the final solution and is it circled? So go through and pause the video and try the second example out. All right, so hopefully at this point you have a good grasp on solving multi-step equations. Thank you so much for watching this video. I hope this video tutorial really helped to kind of narrow down an understanding of how to solve multi-step equations. Thank you all so much for watching. I hope this helped. Bye, everyone.